Hello everyone. My name is Ahmed Bougrian. I'm field application engineer based in Japan, Tokyo office. So it's always a real pleasure to be with you today to talk about an important topic, which is about post-quantum cryptography. So today we'll see what is the post-quantum cryptography, why it's a very important topic, and also to see how to face the challenges and how to secure our future application. So of course, after the presentation, feel free to reach me through my mail address. So now, just to talk a little bit about me. So I've been working with security since 4 years now as a pre-sales engineer. So I start first to work on the HQ in France, which is based in Rennes. And then I decided to move to Japan to be more close to our customer in Asia. So my goal is to really be close to our customer, to understand their needs, and to ensure all the technical question, and also most important, to provide them the best cybersecurity solution. So I'm involved on all the vertical markets, such as automotive, semiconductor, defense, and space. And also, just to talk a little bit about my background. So I have engineering degree in electronics and embedded system. So this is also key for me, to have a nice view on the system. So today, what I plan to do is to separate on a few topics. So first, it will be about security introduction. So we'll briefly introduce security. Then I will talk about post-quantum cryptography. So first, to define what is post-quantum cryptography and why it is so important. I will also try to give you some context and challenges, because it's not only about implementing post-quantum cryptography, but it's how to evolve the way security is managed over the life cycle, over the time. And finally, I will present you security unique post-quantum solution with different flavor. So let's jump directly to security introduction. So here the first point I want to emphasize is that security is very important and very key. So we need to ensure that data is trusted during the whole life cycle, and security have unique vision to partner with our customer in order to provide them the best end-to-end cybersecurity from the chip to the cloud. So this is very important for us. And also, we truly believe that one day security will be worth more than the device itself. So now, just to mention about security history. So I will just highlight some key points. So security was founded in 2010 as a famous spin-off of the French University Telecom Paris. So this is important because this shows our DNA and who we are. So we are from research, which give us, always a step ahead on the cutting edge of the technology, and also, the way to answer new challenges. Also, we directly open new offices, especially in Asia, because it's a very important market for us. So in Singapore and Japan, where I'm working at the moment. So we expand a lot, and we also have some key figures. So we deploy more than 1 billion IP per quarter. We also acquire competitor in Europe, for instance, and so on. So we have now the most important portfolio on the market. And finally, the very key point is to mention that we celebrate our 15th anniversary, and we've been acquired by Cadence. So this is a very exciting news because we will be now the security part of Cadence. So very exciting news. Also, on some very briefly, some key points. So, our IP are fully digital, and also it's patented by Security. We have experience with many customers worldwide, many projects, many scientific paper, and also we deploy our technology down to 2 nanometer, which is uh, quite impressive. So now, in terms of approach, we have a unique approach, which is the desk approach. It's based on protect, evaluate, service, and certify. So for that, we have 3 business lines. So the first business line is about securizer. So this is really the protection part. So here we provide to our customer hardware security solution, which can be provided as standalone in order to answer some very specific needs, but also to provide the full security, which will be embedded on subsystem. So this is called integrated secure element. So here it's really a complex architecture with all the security needed, the root of trust inside, to really offer the best cybersecurity solution on the chip. And also, of course, on top of that, we have the full software solution, so the full software package. Second business line is about evaluation part, so it's called Laborizer. So this is really to do complete end-to-end hardware and software evaluation. So we have a suite of 3 different tools in order to perform complete security analysis. So we have one tool which is called virtualizer. So this is really at pre-silicon stage. So we do a complete analysis from the RTL to all the steps of the design until the place en route. We have also one which is very important, is about software. So it's called catalyzer. The goal of the catalyzer will be to evaluate the security on the embedded code. So source code, it can be C code, but also on the binary. And the goal would be to check on the code if there is any leakage, any vulnerabilities, to make it as clean as possible. And finally, we have the analyzer part. So analyzer is to do a complete evaluation on the real device. It can be ASICs, FPGA, any board, smartphone, smart card, and so on. And finally, we have the expertiser, which is in order to help our customer to reach their security goals. So this also is very key, especially with the standardization of the product. So we make sure that our customer reach their security goals in terms of standards, for instance, but also in terms of security evaluation to do, for instance, penetration testing, also to support them for consulting, trainings, and so on. So now let's jump to the second topic about what is post-quantum cryptography and why it is important. So first, just to differentiate a little bit. So for decades, we have the classical cryptography, which are famous, such as IDS, ECC, RSA, and so on. So those are well known to be mathematically strong, but it's no more secure anymore, especially with the quantum computer threats. Okay, so the quantum computer threats will be able to easily break those algorithms, which are implanted on all kind of application. So that's why we need to do the transition on the post-quantum cryptography. So post-quantum cryptography are algorithms which are quantum protected. So it means it protects against quantum computer attacks, and also have harder mathematical problem to be solved, and which are very strong and efficient. So I will talk about more precisely about post-quantum cryptography. Sorry. Just to say also that post-quantum cryptography is also can be used with a traditional cryptographic engine. I will show you that on the upcoming slides. So now I will talk about standardization. So this is very important. huge effort has been done on the standardization for a very long time. It started in 2015. And just for you to know that secrecy was involved from the beginning to evaluate all the candidates, okay, by using our tools, for instance, by being involved on the scientific research and so on. So just to summarize that, so in 2024, the NIST standardized three algorithms for post-quantum cryptography. So you have lattice-based. So those are ML-Chem, which was previously named Crystal Kyber, and ML-GSA, which was named Crystal Dilithium. So those are lattice-based, okay? We also have another one, which is hash-based. It was called Sphinx Plus, so it's a GSA. So those are already been standardized. And also, I will show you on the next slide, but you have some regulation also who encourage people to do the transition as soon as possible. Okay. Just to mention that you also have edge-based, which is not part of which have been standardized way before, which are XMSS and LMS. So those are used for secure boot, for instance. And also other candidates will be standardized. So one which is HQC, which is an alternative to ML-Chem for the lattice base. And also something very important is to mention that each country have also their own standardization for the post-quantum cryptography. So one thing I can mention is, for instance, in Korea. So it was last January. The Korean government so select the final 4 algorithm, and secrecy also been very proactive on this by working with scientific and on publication on that. Also, of course, in France, in Europe, and so on. So the key point is we keep an eye on the NIST, of course, which is very important, but also all the different countries to offer unique solution. So now, why post-quantum cryptographic is important? So it's important because first, the threat of quantum computer, it's a very serious threat. Also, it means we need to adapt everything. It's not only about hardware implementation, but also to make sure that during the whole life cycle, it's fully secure and adapted to post-quantum cryptography. Also, we capture. We have some. So this I already mentioned about post-quantum cryptographic, and very key point is also about standardization. So it's already been standardized, and also we have a lot of regulation. So, for instance, CMSA in the US, which encourage people to do the transition to post-quantum cryptography. So, as you can see, the plan is to be available, to be implemented. So for 2030, so it's coming fast. And if you're looking, for instance, on automotive, where the lifetime is very long, it's now, and it's very important to make sure to adapt it now before it's too late. Also, you have other timeline in UK, for instance, and so on. And finally, just to say one word that NIST launch new reports about cryptographic standards. And what it says that for now, the critical algorithm, they will put some warning. And I think it was in 2028, it will be not used anymore. And finally, sorry, after 2030, it will be disabled. So you see, so at some point, everyone have to use the transition soon. So post-quantum cryptography, it's allow to have to secure the data against both classical and quantum attack. and to ensure very long-term security for devices on all the vertical, automotive, IoT, and so on. So this is key and very important. So now let's jump to the context and challenges. So the important point is, security need to be maintained through the lifetime of the product. So this is very important to make sure that data is trusted from the beginning to the end of life of the product. So this is important, and also we need to links to all the new regulation and standards. We need to adopt new security new security trends. Let's say we need to increase the data protection, software updates. So all those need to be more important and present during the whole life cycle. So this is very important. So we need to prepare for that. So we need to make sure that, as I said at the beginning, everything is trusted from the beginning to the end of life of the product. Also, something very important is you have like the value chain, so you have many players, and you need to really make sure that everything is secure and you have no leakage and so on. So that's why you need to manage the security differently. So for now, it's managed on the static way. It's mean we do like remote action, which require high expertise, require engineering and so on. It's also very costly. So now we need to, by using the cloud, for instance, to make sure to have like security services during the whole value chain to ensure that we are able to do secure updates on the air, for instance, to monitor all the physical and cyber attacks, to be able to do secure debug, to also do provisioning and so on. So we really need to do the transition on that. And security is really a key player on that. So to make sure that everything is trusted from the chip to the cloud. So this is what I was saying. So at security, we have this unique vision to have the chip to cloud solution with security services on the cloud side in order to, for instance, manage a fleet of devices, to do all the security services I listed, and to make sure that data is really trusted during the whole value chain. So just one word about standards. So as I mentioned, it will be, the CNSA launched the recommendation, which are MLKM, MLGSA, XMSS, LMS for secure boot and so on. So yeah, so I will just briefly, because I think I'm running out of time, I will just give you some use cases. So just to make sure that, to say that post-quantum cryptography is widely used, for instance, to do a firmware verification by using MLGSA or by using XMSS or LMS. Also to do key exchange by using MLKM, for instance, and also to do all the, the security for MARSEC, IP-Sec, TLS. So yeah. And finally, what I want to mention is about our security solution. So Security are very proud to say that Security is the first worldwide to be CABP certified on the hardware for the post-quantum cryptography. So lattice-based MLKM and MLGSA with the associated algorithm such as SHA-3, Shake, which are used with lattice-based. Okay. And also at Security we have different flavor. So we have the standalone IP. So this is basically the lattice-based accelerator with the function needed to perform that. Okay. And also, of course, on top with the software associated. And we have different flavor, which can be embedded either on crypto solution. So crypto solution is a bundle of cryptographic IP, so classical algorithm combined with the post-quantum cryptography. And finally, to have the option on the ISC. So this is the architecture of the integrated secure elements. As you can see, the post-quantum cryptography is implemented on the ISC, and you'll be able to do secure boot and firmware update, for instance, using GSA. So also, the key point is we really need to do the transition to the post-quantum cryptography during the project life. So as you can see, we have some very important pillar to make sure that we ensure the crypto agility. What does it mean? It means to be able to enable some specific cipher, for example, in the future, to have like adaptability of the firmware over the air, memory size, to be able to support updates and so on. So this is also very important, is we keeping evolving and make sure to ensure this transition to post-quantum cryptography. And finally, so this is just to summarize a little bit. So we have the ISSP, which is Integrated Security Services Platform. You have the integrated secure element with all the security needed. On the host side, you have what we call secure, the software agents who will do the bridge between the SOC part and the cloud side, which will offer security services such as provisioning, update of the air, and so on. Okay. So this is really the full solution chip to cloud to make sure that everything is trusted during the whole life cycle and during the whole value chain. So conclusion on that part, PQC is very important today, as I try to explain why. It's because of the standardization, all the regulation will make it mandatory to be used. Also, with the serious threats of a quantum computer. And as you can see, we have future-proof and hybrid solution, which is available on all the different flavors to answer customer needs. And finally, we also have post-quantum cryptographic evaluation kit. So this is a PQC which is embedded on the FPGA board, and basically customer can evaluate our PQC performances, see how it's work and so on. So this is also very important for customer, to have hands-on needs and to make sure that performances are well done. Okay. So yeah, so thank you everyone. Sorry if I was a little bit late on my presentation. I will let you also scan this QR code to have more information. It's a white paper. And yeah, thank you everyone. Have a good day. And if you have any question, just don't hesitate to ask Security or to just send me a mail through my my address. Thank you everyone.